All right, can you guys hear me okay? Cool. So, my name is Mike. I work at a company called Pengen, and we are the company that makes a NoSQL database called MongoDB. How many of you have already heard of it? How many of you have used it at some point? Okay, so a few people. Elliot gave a really great introduction. This is going to be really helpful, so I don't have to do quite as much background. So MongoDB is a NoSQL document-oriented database. So of the categories that Elliot mentioned, MongoDB falls into the document-oriented category. So just as a quick overview, if you were to compare Mongo to some of those other databases that Elliot mentioned, MongoDB is sort of designed to fit sort of a sweet spot between having a lot of features, but also having really good performance. So if you were to compare it to something like a relational database that does traditional SQL queries, it doesn't have quite as much sophisticated query capabilities like groups and joins and things like that. But on the other hand, it also gets really great performance at running really fast read queries and scaling really well across multiple nodes. So just a little bit deeper on that. So since Mongo is document-oriented, each record in the database is, you can think of it like a document that's composed of something like JSON. So JSON is just a set of keys and values. So a document doesn't need to have certain columns, or it could have different data types in some columns than others across the entire table. So you might have one user document that has an age field, another user doesn't have the field at all. You might have a location field that contains a nested object that contains a city and a state, or it could just be a string. There's no restriction that tells you that you have to have the same data type across the entire table for one field. So that's what we mean when we say schemaless, basically. However, it does provide functionality to do rich queries. So you can do some pretty sophisticated stuff that comes close to doing a lot of things that you would normally do with SQL. So you can do things like range queries. So here's an example where I'm querying the users table to find a user whose last name is Smith, where their age is greater than 10. So that's just a basic example. You can do a whole lot more stuff like that. You can also create indexes, secondary indexes across any field. You can also create nested objects and arrays as your data types. So if you have a document that has some relationship to another entity in your business logic, then rather than have multiple tables that split this relationship into two completely separate tables, you could nest them into one document and store them locally. And because things are designed to take advantage of having locality of data, that's sort of what enables Mongo to be designed to be scaled horizontally. So since you don't have to do joins across multiple machines across the network, it's easy to take chunks of your data, split them apart, and store them on multiple machines. So today I'm basically going to be focusing on one particular feature of Mongo, which was added in the previous release, 2.2, and that's the aggregation framework. So the aggregation framework is made to address one of the limitations that Elliot mentioned, which is when you have a NoSQL database, how do you accomplish some of the things that you're used to doing in SQL, like groups and joins, or counting, averaging, things that take batches of data and do some kind of computations on them. So in a SQL RMS, RDBMS, you're used to doing things like join, group by, average, count, sum, first, last, things that, various functions that you can mix into your SQL queries to do aggregations. So in Mongo, version 2.0 and previous, the only option to do things like that was MapReduce. So MapReduce still exists, but now, as of 2.2, we have a new feature called the aggregation framework, which can make it easier to do a lot of this stuff without having to write MapReduce code. So if you're not familiar with MapReduce already, the basic idea is it happens in two phases. There's the map phase and the reduce phase. So the map phase consists of a function that you write that executes against each record in your database and spits out some key and value. And then the MapReduce framework, could be Hadoop, could be Mongo native MapReduce or whatever, collects all these keys and values, groups them together by key, passes them into the reduce phase. And the reduce phase takes each group that was collected by key and executes your reduce function against them. So this you could use to spit out some key and value that aggregates against a particular field in your data, computes an average or whatever, spits out a result. So that's fine, but there's a few issues with using MapReduce a lot in Mongo. So in the Mongo world, it's really powerful, but a lot of times it's way more than you actually need. So what we saw was a lot of people relying on MapReduce to do pretty basic stuff, and that could create some issues. So some of these issues are, in Mongo, you write your MapReduce code in JavaScript, and sometimes it's easy to get things wrong. You can write some code and you have to debug it, and you have to do sort of a trial and error process to make sure that your MapReduce code is actually doing what you want it to do. So this is a lot more work than we think should be necessary for actually doing an aggregation type of job. So that was the motivation behind introducing the aggregation framework. So the aggregation framework is declarative, meaning that you don't actually write code. You write, basically, you write a structure that indicates how your data is going to be processed, but it's not writing like JavaScript code. And because it doesn't use a JavaScript interpreter, we can implement it directly in C++, which is it's part of the native code that the database is built on. So now we can do some interesting stuff. Now that we've got a framework built around it, if we want to extend it with new operations based on interesting things people want to do, we can just create new operators. So to show you what some of this stuff looks like, well, first of all, the way the aggregation framework works is it takes your input, which is your collection, your database table, think of it that way, and feeds it into what's called a pipeline. So a pipeline is basically a set of operators that your data passes through one step at a time, and each step in the pipeline transforms its data, sends it to the next stage in the pipeline. So then once it reaches the last stage of the pipeline, it sends its output to the result. So to run an aggregation command, it looks something like this. You call db.collectionname.aggregate, and you give it this list of pipeline operators. So each one of these objects is a pipeline operator. So in the shell, if you've worked at the MongoDB shell, it's basically a new helper method that's attached to the collection object in the shell. And you can just you construct your pipeline operators in JSON and pass it into that function. So the output looks something like this. The output's a document that contains a result field, and the result field is an array. Each element in the result field is a single output document from your pipeline. And there's also an OK field that indicates success or failure. So if you screw up a pipeline operator or you run out of memory or something, it'll give you a 0. So now to talk about what the actual pipeline does. So the input to the pipeline is a collection, and each step in the pipeline is like a transformation function. So you can think of it sort of like Unix, where on the command line in Unix you can type a command and then use the pipe operator, and the pipe operator will send that output to another process, and you can chain them together as long as you want, and then whatever your output is gets printed to the screen. So now we're going to go through a couple of pipeline operators so you can see what this will actually do, and do a couple examples and sort of compare them to what you might have done in SQL that's comparable to these aggregation tasks. So the first pipeline operator, which is really important, is the $match. So $match basically takes your input and filters it based on some constraint. So let's say I have a bunch of documents that are like, each document has an author, a count of page views, and a title. The title has some content. I can give it a filter like $match author equals Bob, and that will restrict every document that comes in to be some document that has author Bob. So the next step of the pipeline will only see documents that match that filter. So you can filter on any data type the same way that you would filter on data with the Mongo query. So if you're already familiar with the Mongo query language, it's the exact same thing that you would use here. And it takes advantage of indexes, it takes advantage of basically all the same mechanisms that happen when you run a regular query in Mongo. So the next step, the next pipeline operator I'm going to talk about, which is pretty useful, is unwind. So unwind is, well, first of all, as I mentioned before, in Mongo you're not restricted to scalar data types. You can use things like arrays or objects in your documents. So for example, in this document up here, I have a document that contains a field called tags. And the tags field has is an array that contains a bunch of strings. So the unwind operator can actually take that document that comes from the input of the pipeline and explodes the array into new documents so that each element in the array now becomes a new document in the pipeline stream. So in this case, if I use unwind on the tags field, it would produce one output document for each element in the tags field. So it would look something like that. So basically, you get the output you get is the exact same document as the input, except that array is replaced with each single value from the array. Okay, so the next one, now it starts to get interesting, is the $group operator. So the $group operator is where you can do some interesting stuff that groups documents together and squishes them based on some function and spits out a single result document. So $group basically looks at the field _ID that you give it and uses that as the sort of the field to look at for bucketing. And then the rest of the fields are computed based on whatever else you give it. So in this case, I'm giving it _ID author, meaning I want to group all these documents by author. And then I'm giving it a views per author field, which I'm just creating by adding it to this pipeline operator. And views per author is calculated by giving it $sum page views. So it's going to take the sum operator and apply it to the page views field and give me a sum for all the page views in that group of authors. So you can do some other calculations besides sum. You can do max and min or average. You can get the first or last of a group. You can also do add to set and push. So add to set and push let you construct new arrays. So if I have documents that have documents in a group and I want to take fields from that group and squish them into one array that contains values from each document, then I can use push. If you want to do the same thing but also maintain uniqueness within that array, so you never have repeat values in the array, use add to set. Yeah, so this is basically a breakdown of what I just covered. So you can do basically create any field you want by adding it to the fields in the group object, and give it some operators that computes the output fields. So now that we've covered a few of the interesting pipeline operators that can sort of go through an example. So in English, let's say you have a bunch of orders with prices, and you basically want to find the sum of all the prices that were placed by customer number 4. So in SQL, you would do something like this: select some price from orders where customer ID equals 4. Pretty straightforward. So in Mongo, assuming that you have a table that consists of a similar structure, where you have a customer ID and a price, you would do $match customer ID 4. So give me all the documents where customer ID was 4, and then use the $group. So for all of those in the group, apply _ID null. So if you use _ID null, it means just use one bucket for all the documents, don't bucket for each value. And then get the sum by using the $sum operator. And take the result, stick it in the field called total. So another example that uses unwind. Let's say you had a structure where you had a table that consists of blog posts, and each blog post has an author. They have tags. So if you wanted to find a list of authors that have written some post under each tag, you could do something like this. So the SQL query looks something like this. It's a little bit complicated, but you do select a bunch of fields from, and then you have to left join it to your post, because we're assuming that you'd be storing your tags and your posts in different tables. And then you have to do group by, and then select the result. So Mongo, first of all, in Mongo, you wouldn't have put these in separate tables. In Mongo, since you design your data around the way that it's presented rather than how it's stored in separate tables, you probably have something like a table that contains posts, and each post would have an author field and a tags field, and the tags field will be an array. So here we can unwind the tags array, and then group by those tags, and take the result of that grouping and squish them into an output field called authors, which is just a unique set of all the authors that we found in that group. So a couple more operators that I can talk about are skip, limit, and sort. So if you've ever used Mongo from the shell, there's .skip, .limit, and .sort, which are options that you can apply to a query to do pagination. For skip and limit, do pagination. So if you want like the first 10 results starting from the 20th result sorted by date, then you can use these three. So these let you filter how much data goes into your operator pipeline, and lets you limit, or lets you sort by a specific field. So if you wanted to keep all of your data in the pipeline sorted by date, or sorted by name, or whatever field you want, you can use .sort. Same thing applies to $sort in the pipeline operators. So the way you do this the way you specify these operators is the same way that you construct an index key in Mongo. So if you've ever created an index in Mongo, basically it's an object that consists of a field, colon, and then either 1 or -1 if you want to do sorting, ascending or descending. So the same thing applies here. So if you want to use $first or $last, obviously you have to use sort, because first and last don't have any meaning if you haven't sorted by some field. So limit and skip, as I mentioned, same thing. You just give it $limit or $skip, and then you give it an integer that tells you how many documents you want to limit or how many you want to skip. So $project can do a lot of different things. You can basically reshape documents in the pipeline. So you can delete fields, you can add new fields that you compute based on some values, or you can move fields around in the documents. So just a couple examples. If you have $project and you give it an object that has fields field name field name :1 field that will include the field in your pipeline and throw out everything else. Conversely, if you do field name :0, it will throw out just that field and keep the rest. You can also move fields around. So if you have embedded objects in your documents and you want to reach into that embedded document, take a field inside of it and put it into the top level, you can basically do that by referencing that field with the dot operator. So $category.name looks at the category object inside a document and finds the name field within that object, puts it in the top level under the field called cat name. You can also do the same thing in reverse, populate a new document, a new subdocument using fields in the top level by just constructing it with the new key and embedded object value. So also you can use project to compute new fields. So those operators that I mentioned before, like $sum, same idea here. You can give it things like $add and either reference fields with a string and a $sign to tell you what fields you want to look at, or just give it a literal value like 2. So age fixed, for example, compute by giving it $add and then a bunch of operands. So you give it an expression and a bunch of operands, it'll populate that value in the output with the result of that computation. So the computations you can do, there's quite a few available, so you can do some basic arithmetic, you can do logic, obviously you can nest these as deep as you want if you want to do complex logic or compose functions. You can do some date-related things, extract part of a date like the week or the month. You can also do some string manipulation, and we add quite a few of these with each release as we get a feel for what people are using it for. So here's another quick example of the most recent 1,000 blog posts. How many were published within each calendar year? So in SQL, I don't even know if this SQL is right since I haven't used SQL for quite a while, but it's something like this. So you'd select the year, use the year function to extract the year from a date and a count from this subquery, which is selecting the publication time from posts ordered by publication time descending, and then group that by the year. So in Mongo, it's a similar idea to the table structure I discussed before. So you would use sort, sort to indicate that you want to look at documents sorted by publication time in descending order. Limit to only the first 1,000. So after the first 1,000 come in, you stop looking at input. And then you use project to extract the year, just the year part of the date from the publication time, and then feed that into the group function. So the group function groups by that year that you just extracted and calculates the sum of all the documents, or the sum by using value of 1 per document. So the sum of 1 per document for all those years gives you the number published per year. So just a couple usage notes in BSON. So BSON is the storage format that MongoDB uses. So it's basically the same idea as JSON, but it's serializable to binary. So it can be stored on disk or transmitted over the network. Since it's BSON, in BSON order matters. So it's not like JSON where you can treat it like a hash table and things just show up in sort of indeterminate order. The order actually matters in BSON. So whenever you compute new fields, they always get appended to the end of your documents. And also, so you might have seen that I use $sign in front of some of the field names. And the idea from that is that we can use that to distinguish a field name from a string literal, because Mongo prevents you from storing a field name that starts with a $sign. So that's just how we maintain the difference between the two. So when you're actually using it in production, some of the things to think about are performance. So usually it's good to use match, sort, and limit in the pipeline as early as possible. And the reason for that is that it limits the amount of memory overhead that the server needs to use, makes the queries a lot simpler. So things like the $group operator have to see all the input from their entire pipeline in order to apply the function. So designing your pipeline to try to use minimal amount of memory can help the performance quite a bit. So also, as far as performance goes, you can use $project to remove fields that you don't need. So if you have really big documents, but you're only aggregating based on a few values, you can use project and get rid of the fields that you don't actually need. So that cuts down on memory usage, gives you a big boost of performance. The other thing to think about is that documents in Mongo are limited to 16 megabytes. So if you transform these documents, the limit of the output is 16 megabytes per document. So that's another thing to keep in mind. So a lot of people also ask us, now that we've introduced this, how does it relate to MapReduce? Is MapReduce going away or is it being phased out? The answer is no. We still work on MapReduce pretty heavily. So this framework is geared towards doing things like counting, accumulating, grouping, basic stuff, but stuff that covers a really wide range of useful applications. So if you need something that goes beyond that, you can always fall back to MapReduce, because MapReduce, you write your MapReduce code, it's just writing JavaScript code. You can have it do pretty much anything you can dream up. So anything that you can't accomplish with aggregation framework, you can always just write it in MapReduce. And you don't have that 16 megabyte constraint on the output size of MapReduce. Since JavaScript and MapReduce isn't limited to any fixed set of expressions, you can basically have it do anything you want. So as far as MapReduce is concerned, it's still used pretty heavily, but aggregation is also picking up less. So anyway, that's all I got. If anybody has any questions, feel free to ask away. Thank you.
We're going to do we're just going to do we're going to set up for a minute and then do a Q&A. And you can